Hi, you're here with Mr. Canada today, and we're doing power law for indices. We call it power law because, well, even though we've been doing powers this whole time, now we're doing a power to a power. So there's a lot of power to be there. So here, if we did multiplication law had to do with adding, division law had to do with subtraction. So power law, well, what's our next operator that we learned growing up? Multiplication. So anytime you have a power to another power, we simply multiply the two powers together. So it's actually probably one of the most favored ones, and the reason it happens is this. So consider we have something like a cubed all to the power of 4. So inside of the bracket, right, that blue 4 is telling us, well, whatever is inside of our bracket, we have to write out with multiplication. So that's a to the power 3 times by a to the power 3 times by a to the power 3 times a to the power 3, right? We times it 4 times. But we could break up each one of those a to the power 3s into just a times a times a times a. We don't need to because we know the multiplication law. We can add those all together. We'll find it's a to the 12. Well, look here, because if we just multiply 3 times 4, that's 12. Right? So this is where the power law comes in handy. We don't have to do all this work. It helps simplify and cancel stuff out quite easily. So for the first one, we just are going to multiply these together. So we get x to the 3 times 5, x to the 15. Here, the next one, it's a little bit harder. So I'm going to take care of the y's first. So what's 4 times 2? Well, that's y to the 8. Now, this square, remember it's doing everything. So we're actually squaring the 2 as well. So here, we actually are going to get 4y to the 8. So keep in mind, when you bring an indice in, we bring it into everything. So we're bringing it here and to here. Just like we kind of expand brackets. We're expanding indices. So this one, I'm going to write this one out a little bit bigger because it's really confusing. It's not going to simplify well, but I wanted to show you something kind of really, really challenging or challenging looking. Right? So we have this 3. Right? That's what we're given. I'm going to take away this 3 right here, and I'm going to write it here. Because that's really what we're doing. Okay? When we bring something in, right? So I brought it in right there. So we can now write out, oh, forgot one more other spot. So don't forget, it has to go to every term. So 2 to the power of 3, a to the power of 9, and then b to the power of, well, 3 times 2 is 6, and then c. Okay? So we get 8, a to the 9, b to the 6, c. That's as simple as I can get. It doesn't really look very simple, but we got rid of the power, which is what the whole goal was. So it doesn't matter that we don't know what it means. We don't really care because it's just something that we could say it's an equation for calculating, I don't know, spin on a basketball. It doesn't, but I'm just saying this is where we could kind of use it. Some complicated things explain very basic ideas. So here is 9 practice problems. The first 3, 4 of them are very straightforward. If you can calculate a value and you want to, go ahead. If not, just simplify. 5, 6 are a little bit more challenging. 7, keep an eye out. There's some little tricks in there. But if you treat it as one step at a time, and then so on, 8 and 9 are quite challenging. So pause the video, try your best, and then we'll come back and go through these. Hey, welcome back. So here we're doing x to the 2 times 3. That means x to the power of 6. Here, same thing. 3 times 2 is just x to the 6. So it doesn't matter which way we multiply, but we know that already. Here, we're doing 6 to the power of 6. Next, 2 times 5 is 10, so 3 to the 10. Here, we're bringing this 2 in to both terms. So 2 squared, and then x to the 2 times 2. So we can simplify that as 4x to the 4. Next, we're bringing this to each here. So here I have 3 to the power of 3 and y to the power of 15, because 5 times 3. And we get 27y to the 15. Next, This one is a lot more challenging. So I'm just going to show you how I always tackle these the first time, especially when I haven't done them in a while. I'm just going to leave that x alone because we can just always multiply by after. Let's bring this 3 in the inside. So I'm going to write nice big brackets. 2 to the 3. 2 times 3 is 6. Y to the 3. Okay. So now let's multiply this x into here. So we get 2 to the 3, x to the 7, y cubed. And then we can just get rid of that 2 to the 3 and write 8, x to the 7, y cubed. Okay, not that bad. So here, when you see a division sign like this, especially with algebra, get rid of it and write it like a fraction. Okay, so here, we're going to just rewrite it as 2x squared, all cubed, divided by 4x cubed. Okay. So here, let's get rid of this bracket first. So let's do the power law. So here we're going to get 2 to the power of 3, and then x to the power of 6. And we're going to divide this by, well, I'm actually going to do something that we'll get into later, but I'm going to change this 4 into a 2 squared. Okay? That's actually something I'll talk about later called change of base, but I'm just going to do that little tricky trick there. Because we can break up the top as 2 squared times by 2 times by x to the 6, or even x to the 6 we can break up as x to the 3 times by x to the 3, right? Because we just add those. And we can write that over 2 squared x cubed. So we can actually then cross out this 2 squared and this 2 squared because it'll be 1. And then this x cubed with one of the x cubes. So we can write our final answer as 2x cubed. You would have found out that similarly the other way, because you would have had 8 divided by 4 is 2, and x to the 6 minus x to the 3. But there's just different ways to go about simplifying. So don't ever assume there's just one straightforward way. There's many. And then this last one, I'm not going to go through maybe all the process, but I'm going to first get rid of that power law. So here, 5, and then this will be 8a cubed b cubed x to the 6. And then I'm also just going to put these ab inside. So here we go 5 times 8 is 40. And we bring that a to the front, a to the 4, b to the 4, x to the 6. And we're done. So it's actually, in my mind, easier than the last one. It just looks a lot scarier.